So here is another question on projectile motion with angular projection. So it is given that show that there are two angles of projection for which the horizontal range is the same. Also show that the sum of maximum heights for these two respective angles, it is independent of the angle of projection. Okay, so here the two important parameters which are associated with this question, they are, first is horizontal range. Okay, let me use a different ink. Horizontal range, and then we have maximum height, these two. So here, if you remember the formula, it is great, otherwise you have to go on deriving again. So my tip to you, my advice to you, have the formula ready with you, try to remember the formula. So the formula for horizontal range is u square sine 2 theta by g. Okay, u square sine 2 theta by g. So this is the horizontal range for angle theta. Okay, this is the horizontal range for projection angle theta. So we will call it as, let's say, r theta. Okay, now suppose we replace this angle theta, okay, we replace this angle theta with 90 degree minus theta. Okay, 90 degree minus theta. We replace this theta here with 90 degree minus theta. Then the range will be, we'll call it 90 degree minus theta, that is equal to u square sine 2 into 90 degree minus theta, because we have replaced theta with 90 degree minus theta. This is the new projection angle. So in that case, it will be equal to u square sine 2 into 90 degree minus theta by g, which is equal to u square sine 180 degree minus 2 theta. 2 into 90 degree, that is 180 degree. 2 into theta, that is 2 theta by g. Now we all know sine 180 minus anything, that is equal to the same ASTC rule. So according to it, will be sine will be positive, and sine 180 degree minus whatever angle, it will be the same. So here it will be equal to u square sine 2 theta by g. So here this is also u square sine 2 theta by g, and this is also u square sine 2 theta by g. The horizontal range for projection angle theta is equal to the horizontal range for projection angle r 90 degree minus theta. So the first part of the question we have proved mathematically. Then is the second part, which is the sum of maximum heights for these two projection angles, that is theta and 90 degree minus theta. It is independent of the angle of projection, that is there will be no sign of theta in the final expression. So let's see if it is actually true or not. So okay, first the formula of maximum height. So maximum height is equal to u square sine square theta by 2g. So this is for projection angle theta, so we can call it h max theta. Okay, maximum height for projection angle theta. Suppose we replace theta with 90 degree minus theta. In that case, the maximum height will be equal to, we'll call it h max 90 degree minus theta. That will be equal to u square sine 90 degree minus theta whole square by 2g. Now we all know sine 90 degree minus theta, that is equal to cos theta. So it will be equal to u square cos square theta by 2g. So this is h max theta, this is h max 90 degree minus theta, that is maximum height for the two angles. So if we add them together, okay, h max theta plus h max 90 degree minus theta, we will have u square sine square theta by 2g plus u square cos square theta by 2g. So here u square by 2g is common, then we have sine square theta plus cos square theta. Sine square theta plus cos square theta, that is equal to 1. So we will have u square by 2g. Now here, according to the question, we have to show that the sum of the maximum heights for angles theta and 90 degree minus theta, for which the horizontal range stays the same, that will be independent of the projection angle. So here there is no theta parameter in the final expression. It is only u square by 2g. No theta is present. So it is independent of the projection angle. Okay, it is independent of the projection angle. Okay, so here we have proved this also mathematically. This is the second part of the problem, and this was the first part here, this one, that the horizontal range for two projection angles, there are two projection angles for which horizontal range are same. So here we determine that those two angles are any angle theta and its complementary angle 90 degree minus theta, that. And for these two projection angles, the sum of the maximum heights is independent of the angle. So that also we proved here. Okay, so this is it. So basically what it is saying is that suppose we have a projectile, okay, and we launch it with two projection angles. Let's say the first projection angle is theta, okay, and the second projection angle is its complementary angle 90 degree minus theta, okay, 90 degree minus theta. So in both the cases the horizontal range will be the same. Okay, and in this case also it will be the same. Okay, the horizontal range will stay the same for both the cases, and the sum of the maximum heights, okay, h max theta and h max 90 degree minus theta, the sum of these two will be independent of their respective projection angles, whether it is theta or 90 degree minus theta, whatever it is. Okay, so this is the basic concept. So here is another question on projectile motion with angular projection. So it is given that the horizontal range of a projectile is 4√3 times of its maximum height. Calculate the angle of projection. Okay, so a very direct question, and it revolves around two important parameters, which is horizontal range and maximum height. And here there is a relationship which exists between these two, and it says that the horizontal range is 4 root 3 times of its maximum height. This. Okay, so if we bring it in this form, H max by R is equal to 1 by 4 root 3. Okay, this is the relationship. Now why I brought this in this format? If you recall, we derived a relationship between maximum height and horizontal range, which is H max by R is equal to 1 by 4 tan theta. Okay, so let's say this is the first equation and this is the relationship which we have. So if we compare these two equations, we will have 1 by 4 tan theta is equal to 1 by 4 into 1 by root 3. So 1 by 4 will get cancelled. That implies tan theta is equal to 1 by root 3. That implies theta is equal to tan inverse of 1 by root 3, which is 30 degree. Okay, 30 degree. Okay, so if you recall this, if you are able to recall this relationship between maximum height and horizontal range, then you can solve it in a matter of a few seconds. But suppose you are not able to recall this relationship, then you have to go with the formula approach. You have to recall the individual formula, where maximum height H max is equal to u square sine square theta by 2g. Okay, and horizontal range is equal to u square sine 2 theta by g. Okay, so here it is given, up to this it is the same, H max by R is equal to 1 by 4 root 3. So now here if we do that, H max by R, it will be equal to u square sine square theta by 2g divided by u square sine 2 theta by g, which is equal to u square, let me write it as sine theta into sine theta. Okay, so that will be easy when I cancel out the parameters, 2g into g by u square into 2 sine theta into cos theta, because sine 2 theta is equal to 2 sine theta into cos theta. Okay, so here u square will get cancelled, g will get cancelled, sine theta will get cancelled. So we'll have sine theta by cos theta and 1 by 2 into 1 by 2 into sine theta by cos theta, which is equal to how much? 1 by 4 tan theta. So same relationship we arrived using this individual formula approach. So it will be a bit lengthy, but if you are not able to recall this relationship, you can go with the individual form. Now the remaining steps, they are the same. 1 by 4 tan theta is equal to 1 by 4 root 3, tan theta is equal to this much, and you will get the result. So if you are able to remember the formula, this relationship, it's great. If you are not, still you have this approach with you, a bit time taking, but you will arrive at the same result. Okay,